Hello, hello. We are on to our second section of chapter 9 on non-right triangles, but remember, it works for all triangles. This is called the cosine rule, and what it does, it helps us find lengths and angles of all triangles. The picture that we have here is, labeled correctly. Lowercase is all the lengths, and uppercase are the angle measures, and they give you all these crazy equations. Now, I want you to know these are all the same thing. They're just looking at a different angle. Here's what you need to take. This right here is side angle side, and this is that opposite side. Now, what the heck do I mean by that? Let's just look at the first one. Notice the variables on the other side are little b, little c, little b, little c, and capital A. Little b, little c, and capital A. Notice that is the side angle side. And so when we have that information, we can put it together and solve for this opposite side. There's only one formula here. If you have the side angle side, this is what we use to find the opposite side. All right, so I don't believe it. I don't think you should either. So let's see if we can derive it. All right, so there is a triangle, capital A, B, and C. I've got little c, little b, and little a, but I've added this height to it. I've added this height, and notice I've called this length here is x. Since the whole thing is a, this has to be a minus x. Easy peasy. It's created two right triangles, and that's the thing to notice. Two right triangles, right here and right here. Anytime you're in a right triangle, that means Pythagorean theorem is going to work out. SOHCAHTOA is going to work out. So this is the brilliance of this derivation. It uses those kind of three different equations, mixes them all up, and creates this one relationship between the sides. So let's check it out. I'll just show you all of them. Doesn't matter. All right. Let's just get rid of that. Okay, so first of all, where is this equation coming from? Well, if you look at the triangle, if you look at this right triangle here, you're saying this hypotenuse is equal to this squared is equal to the hypotenuse squared. So c squared equals a minus x squared plus h squared. All right, wait a minute, I got this. I multiplied this all out, maybe rearranged a few things, but that's it. This is nothing more than the Pythagorean theorem. We go to the other side and we have a little bit easier deal here because we have x, h, and b. So b squared is equal to x squared plus h squared. All right. And then finally, one more look at this. And what we have here is if we're at this angle right here, if I wanted to find the cosine of that angle, the cosine is the adjacent over the hypotenuse, or adjacent over hypotenuse. And if I solve that for x, I get b, multiply both sides by b cosine c. No big deal. All right, so how do these three all work together? Well, notice I've got x squared plus h squared, which is right here. So I know that this boils down to b squared. And if I want to keep this a nice clean formula, it's got little a's or little lowercase a, b, and c, or uppercase a, b, and c. And this x is kind of driving me crazy. So we do have a relationship that we can plug in for x to keep it in the a, b's, and c's family. So what we do is we plug it in right there. Once we do that, this becomes b squared. There's the a squared. So there's those. Minus 2a times b cosine c. So the law of cosines is nothing more than taking any triangle, cutting it into two right triangles, Pythagorean theorem, one cosine from one angle, putting the three equations together and making one. Sure, it's not the, oh, I wish it was really short and easy, but what's nice is it always works. So that's pretty cool. So let's do our first example. We're walking along and boom, we see this triangle. And if I were you, I would notice right away side angle side. Side angle side really says, hey, we got some things here. Maybe the law of cosines from our earlier chapter, maybe the area. They both, you need to kind of put them both with side angle side. It's a good idea. All right, well, that allows us, law of cosines allows us to find this opposite side. So instead of like using which formula should we use because of the little a's and little b's and little c's, I want you to start generalizing, thinking the thing on the left is the length, so that's BC squared, and these are the 11 and 13 are really those two sides in any order, minus 2 times the 1113 times the cosine of the angle between them, which is the 42. So that is nothing more than writing it. Notice I don't start with, let's see, is it A, is it B, is it C? I start placing the things with the side angle side on this side and the opposite side here. So just do a little bit of math, plug it in my calculator correctly, and take the square root. I get 8.8. So I'm going to point out something with my graphing calculator. I did this. Uh, how you plug it in is really important, and I think that should work right there. So notice that I'm plugging the whole thing in. That's going to save you. The, the calculator knows the order of operations. So notice this is the first thing, and then I get my answer, and then I take the square root of the answer. The answer button is like the second equals or something like that, or I could have just typed in 77.46 and been sure just fine. All right. Well, you knew it. Why don't you give that one a shot? Uh, I'm going to do a lot of examples in the back, so this is not a play pause it. So you need to pause it, find the answer to this, and then I'll show you the answer. Get your calculator out, practice, practice, practice using calculator. A lot of people get the algebra right, but it's the calculator. So, all right, hopefully the pause is over. You've got it done. This is what I ended up with. So I notice that we have side angle side. I'm looking for km squared. So I use the other two in any order. Okay. And that's just plugging it in. So when look at this one. In this case, I did it all in one move. So here I put the square root and then I use this parenthesis and this parenthesis to kind of capture it all. So you can do it all in one if you want. 14.2 looks good. So that's how you find a length. And sure, if you're not given that side angle side, it's not going to work quite right. So I'm going to do another example of what you have to do to adjust it sometimes. And then tomorrow we're going to learn about, next week we're going to learn about a thing called law of sines, where it's a little bit different information and it's not side angle side, it's more like opposites. So you kind of have to understand the situation before you go law of cosines or law of sines. I'm telling you, side angle side, law of cosines. All right, so if you want to find angles, well, you're kind of solving for that, aren't you? So you take your law of cosines, which we've already derived, and solve for cosine C. Get this by itself. So I'm going to subtract a squared and b squared, and then I'm going to divide by that quantity. I'm going to divide the entire side by that quantity, and I get this. And this is correct for the cosine of C. Obviously, I'd get the number and then take the inverse cosine of both sides. What you'll see is this equation written like that has a lot less negative signs. So all they've done is multiplied by a very fancy 1, -1 over -1, and kind of distributed that -1 and got this. So this is going to be our friend. please pay attention. What you really need to know is if you're finding this angle, the only thing that you have to place correctly is, notice those are the opposites. The A and B are the other two sides, but that opposite side needs to be placed where it is right there. So you can't mix this up. You can't be, oh, I think I'll just do this. All right. Okay, here's our example. Oh, it's a written example. That means you better pay attention to the capital letters, what's given, stuff like that. So I drew a picture. And when I draw a picture, I don't overthink it. I just draw a triangle first. I put some letters. Yeah, whoops. I put the long side is 2 and the short side is 308, whatever. Doesn't matter. You got to trust the math. So I kind of lucked out, and it's not too bad here. AB is 7, BC is 5, and CA is 8. Notice we're given 3 sides, and now we're finding the angle. And the angle they want is with the vertices C, so that's right here. So what's important about this? We've got a formula. Great, there it is. What's important is I make sure that 7 is the side opposite. So that definitely needs to be put here. The 5 and the 8 are interchangeable. There you go. All right, so this is where if we were in a classroom, I'd say everybody plug this in your calculator, and I would put under a sign taped to the whiteboard, less than 50%. I claim that less than 50% of the people will plug this into your calculator correctly. And guess what? I'm usually right. Sad. It's sad because I haven't done a good enough job teaching you how to use the calculator. The red parentheses are what people miss. You need to take the entire top divided by the entire bottom. So when you plug this into your calculator, notice these parentheses on the entire top divided by the parentheses around the entire bottom. Okay, really important. You're going to get a number, and then you take the inverse cosine of that number, and in this case, it came out to be a really nice number. The inverse cosine of 0.5, you're asking what angle will give me a cosine value of 0.5, and that is 60 degrees. 60 degrees. Hey, part B there, it says find the exact area. Remember, if you know two sides in the included angle, side angle side, we've got a formula that works for that. And it's always going to be that 1/2 AB sine theta, okay? AB sine theta. Identify two sides in the included angle. We know two sides and we know the included angle. Plug and chug, baby. All right. So this was on the video for today's, this is the video. I'll get back to you. All right. This is your homework. So I thought I'd go through your homework problems and kind of give you a hint here and there. So here we go. This is your hint via video. All right, this one, slam dunk. That's a plug and chug. It's number 1. It's got to be. They're looking for that opposite side. Number 2, you're supposed to do A and C. You know, I just kind of reaffirm the idea that if you're looking for this angle right here, that you make sure that you plug in the formula, if you're looking for that angle, that opposite side goes in that position, okay? You know, make sure when you plug this in your calculator that you're putting parentheses around the entire top and parentheses around the entire bottom. All right. So C is the same thing. Hey, you're clicking on the heading of the homework and it'll get you to the solutions. You're checking your answers. Make sure you're doing this right. And if you get frustrated, just put a I'm frustrated on your homework and let me walk you through it. All right, 4. 4 is the same thing as 2. They actually ask a little bit about the area. Once you know two sides in the included angle, you're good. Number 5 So they give you three sides again. They're asking for an angle again. So, but they ask for the smallest angle. They don't ask for A, B, and C. So the point here is the smallest angle will always be opposite the smallest side. Okay. The largest angle will be opposite the largest side. So 9 is like, what chapter are we in? A quadratic? All right, please pay attention here. What's given in this problem is not side angle side, okay? But this angle dominates. It's like, okay, that centers us. So it kind of pushes the idea that that's a side and that's a side. But Mr. Sayers, we don't know that side. It's X. Well, we can still use the law of cosine, plug it in, and just see what happens. We know this opposite side, so this 7 has got to go on the outside right there. And notice what I use for the two sides. I use 6 and x, just like what I have. I have a 6 and an x. When I plug this in, yeah, it doesn't look that nice, but guess what? I can multiply, I can add, I can subtract, and I'm going to get something x squared. I'm going to get something x, and I'm going to get a number. And I'll bet it's going to look a lot like that. So that's kind of the idea about where it comes from. Now it's kind of saying that if we solve this, there are two values of x that'll make that work. Whoa, there are two lengths that might make that work. Awesome. I want to point out, this is something that I started the other day. What is given? We have angle, side, side. So we have an angle, we have a side, and we have a side. And in fact, watch how I write this. We have an angle, a little s, and a big S. Now, why I do that is I do the little s and the big S to say which one's the longer. This actually is telling me something, and there is only one possible solution for x. Now, to really get into this is to draw a lot of pictures and a lot of motion. We can do that, but I want you to kind of have that in your notes. So when you solve this quadratic, because you will use a quadratic formula to solve this, you should get one positive and one negative, and that's what's telling the math is telling you, hey, the situation only works for this length. The negative, I don't even know what that means. So that's kind of cool. Why do I go so deep into this? Well, you're going to be asked, look at this. The angle kind of centers us. This is a side and this is a side. So once again, we're going to get that situation where we have that quadratic. All right. So I think you can handle it. It's angle side side. It is still this situation. So we expect only one positive value of x when you solve the quadratic. Pretty cool. Pretty cool. I don't even know what happens with C, so have fun with that. Number 11, they're kind of tipping their hat. They're saying, hey, values. So let's kind of look at what's given. They give you an angle, then they give you a side and another side. Now notice I don't put the 40 in between the 6 and the 5 because it's not the angle between the 6 and the 5. So that's angle, big S, little s. All right, in this situation, you can have two possible values of x that'll make this work. It's hard to visualize as a math teacher. I've seen it 1,000 times and I still kind of like fight it a little bit. So I've trained myself to notice this situation, and it's just saying there's a possibility of two lengths for that third side. So you're like, man, I still don't get it. A lot has to happen. This has to be acute angle and this relationship has to happen. I have gone ahead and drawn this to maybe satisfy a little bit. Here's the original triangle. Okay, original triangle. If we extend this side, because we don't know exactly how long it is and it goes on forever, if we do a circle with radius 5 and swing, think about swinging this side, and then it hits right here. It is once again 5, it is again 6, and this is 40. So nothing has changed with the given. The given is 40, 6, and 5. But you can see that there is this triangle and there is this triangle that actually satisfies that. Hey, if our lives are much better if we don't like do this at all. Just teach you the law of cosines and it's good. And this is rarely comes up. But in mathematics, it's good to think about these. Yeah, don't lose sleep over this. Some days you'll catch it. But I'll tell you what, this using the law of cosines to solve for this side always flushes out if there's two sides. So that's the beauty, is you don't have to see the picture. You can trust that the quadratic, if there are two possible sides, you're going to get two positive numbers when you solve the quadratic. And then you're like, oh, I guess there are two possible answers. So that's the nice thing about law of cosines, is that it's a little bit of work, but it always flushes out in this scenario when you're given angle side, if there's one or two possible solutions. All right, so I'm at 21 minutes. I'm going to keep this as, you please use this video to kind of walk yourself through these problems. I don't think I have too many, I didn't ask too many more problems. Have fun with the other ones. Thank you. Appreciate the hard work.